Hello dear friends, a very good evening to everyone. Welcome to Megha's tutorial. In today's video we are going to solve the hstr 2012 PM method paper. Please like the video. Question number 22. Radius of aluminum 27 nucleus in units of Fermi is. So we need to calculate this one. It is using the formula R is equal to R naught into a raised to 1 by 3. We are going to use the formula here. So here we are going to use the formula R is equal to R naught into a raised to 1 divided by 3. A is 27, R naught is 1.2 for me. Finally, we are getting the value of R as 3.6 for me. That is option number 4. We are going to get the answer as 3.6 for me, the radius of the aluminium nucleus. In the units of Fermi is 3.6 for me. That is option number 4. Next, question number 23. A coil having a resistance of 120 ohms and an inductance of 24 Henry is connected across a power supply of 12 volt. The time constant of the circuit is. We are going to use the formula for the time constant. T is equal to L divided by R. Okay. And on dividing, we'll get the answer as 0.2 seconds. Let us see how to solve it. So the formula used here is T is equal to L divided by R. L and R are given here. On dividing 24 divided by 120, you are going to get 0.2 seconds as the time constant value. The inductance of a coil of 120 turns wound on a tube of length 8 cm and diameter 6 cm with relative permittivity 1 is. Okay, the given values are written here and we have to calculate the area of cross section. Using that area of cross section in the self inductance formula, we are going to get the value of L here 0.639 millihenry. Answer for question number 24 is 0.639 millihenry, but here it is not given, so we are going to consider it as a 0.638 millihenry. Anyway, 0.63 millihenry will be the right answer here. Next question, question number 25. You are given two tuning forks here, tuning fork A and B. They produce notes of frequencies 258 Hz and 262 Hz respectively. An unknown note sounded with A produces certain beats. When the same note is sounded with B, the beat frequency gets doubled. Then the frequency is. So we have to calculate the unknown frequency. Another tuning fork is given. Its frequency is to be calculated here. So here is the solution for this one. You'll get the new frequency, that is 254 Hz. The problem is a bit lengthy. You can just pause the video and write it down, or you can take the screenshot here. Answer for the 25th question is 254 Hz. That is option number 2 will be the correct answer here. Next, question number 26. In an experiment, the displacement of the stretched wire of length L is y1 is equal to a sin pi x divided by L sin omega t, and energy is E1. In another experiment, its displacement is y2 is equal to a sin 2 pi x divided by L sin 2 omega t, and the energy is E2. Then you are given 4 options here. You have to choose the correct one. So you are given two equations, y1 and y2. From these two equations, we can deduce that the amplitude is same in both the cases, but the frequency is 2 omega. Frequency will be 2 omega in the second case. That is twice the frequency. Here you are having the frequency here. That is 2 omega. Okay. 2 omega is the value here. But in the first case, we are having only omega is given as pi x here. Okay. Here it is pi x and here it is 2 omega. Okay. So we can say that in the first case, E1 is directly proportional to a square omega square into L omega divided by pi, and in the second case, E2 is directly proportional to a square 2 omega square into L omega divided by pi. So finally we can say that comparing the the two equations, the value of E2, that is energy E2 is equal to 4 times that of the energy E1. This is given in the option number 2. So fourth option will be the correct answer for the question number 26. 7. Television was invented by. Okay, so television was invented by J.L. Baird, that is option number 4. J.L. Baird. Graham Bell, he invented the telephone. Marconi invented the radio, and Thomas Alva Edison, he invented the electric bulb. Television was invented by the scientist named J.L. Baird. Option number 4 will be the correct answer here. Next, question number 28. If RS and RM are respectively the distances of geostationary satellite and moon from the center of the earth, then RM divided by RS is nearly equal to, you have to calculate the radius of the moon to the radius of a satellite, that is geostationary satellite. Their ratio you have to calculate here. So this is a bit theoretical problem here. We have to take the ratio of RM by RS. Just take a screenshot of this one, and later you can write it down. We are going to get the answer as 29 divided by 1 whole raised to 2 divided by 3. That is option number 3 will be the correct answer for this question.